All right, now we're doing 7Q, Reduce My Fraction. This is by Savage William, and 88% of the people like it. We're going to write a function which reduces fractions to their simplest form. Fractions will be presented as an array of strictly positive integers, and the reduced fraction must be returned as an array as well, right? So we're going to get some numerators, and we're going to get a numerator, a denominator, and we're just going to reduce it down and put it in a new array, right? All numerators and denominators will be positive integers. Okay, cool. So what we're going to do here is we're going to first start by declaring the numerator and the denominator using this destructuring assignment syntax, which is an expression that makes it possible to unpack values from arrays or properties from objects into distinct variables. So we're going to go like this: let, and inside of some brackets, we're going to say numerator, okay, and denominator. All right, and we're going to say that equals fraction, because the fraction is going to be coming in just like this. So we might as well just declare it, all right? So now we're going to do a loop, and we're going to what are we going to do? We're going to iterate backwards from the minimum of the two numbers, and we're just going to look for the greatest common factor that way. So we're going to say for, and let iterator equal, and we're going to, like I said, the minimum of these two, so we're going to say Math.min of a fraction. We can't do it like this because we can't have these brackets in there. So to get rid of the brackets, we're just going to use the spread syntax like that, and it just puts the two numbers in there separated by a comma, which is what Math.min is looking for. All right, so now we've got that. We're going to say while iterator is greater than 0, since we're going backwards, we're going to say iterator minus minus, all right? And then put that right here, and we're going to start it up. We're going to do an if statement in here. We're going to say if, and now we're going to see, we're going to find the greatest common factor, right? So we're going to say if, what is it? Numerator, what is this? The remainder operator, iterator equals 0. So basically, as long as there's no remainder when you divide these two numbers, and when we divide the other pair, these two numbers, they have to both equal 0, the remainders. We're going to say return, and then we're going to return numerator. Whoops, we're going to return in brackets, we're going to return numerator divided by iterator. I just might as well just take this, right? All right, comma, just put that there, take this, and then we're going to turn these into slashes for dividing, all right? And that should equal what we're looking for. Let's test it out. All right, good, excellent. Attempt it. All right, 255 milliseconds. That's ridiculously slow. So not only is that a lot of typing, but we need to take this number down a lot. So to do that, we're going to say const here. We're just going to make we're just going to do the concise syntax here. We're going to say reduce equals, and then we're going to turn all of this into an arrow. But we can't even do that. We can't even mess with this yet until we have a greatest common factor function. So we're going to say const greatest common factor, and that's going to equal, we're going to have that equal the numerator and the denominator. All right, And then we're just going to start on the next line because I don't have too much room here. So right here, what we're going to do is we're going to start off by using a ternary operation. And we're going to say denominator, that's not how you spell it, denominator. If that exists, we're going to do, we're going to use some, what is that stuff called? Some recursion, which is basically the act of a function calling itself to solve whatever problem we need. So we're going to say greatest, we're going to take this, why do I keep trying to type this stuff out? Greatest common factor, and inside there we're going to say denominator, and then as the other argument we're going to say numerator, remainder operator, denominator. All right. And basically, let's say we're doing like 8 and 10, right? So 8 here, 10 here. So we're going to put 10 here, and then 8 remainder operator 10 is going to be 2, right? Okay, so now we're going to do it again, and we're going to put the 2 here, and 10 remainder operator 2 is 0. And as we know, we only do that if there is a remainder, right? So if there isn't a remainder, we're just going to say, numerator. Yeah, that's what we're going to do. And that will give us the greatest common factor, all right? And now we can do the reduce thing. And all we have to do for this one is say fraction.map. And for the element, we're just going to use element. And then we're going to say element divided by greatest common factor. Whoops. Greatest common factor. And in here, we're just going to do again with the spread syntax, ... fraction, all right? And let's see if this works. All right, good. And let's attempt it. All right, 12 milliseconds. So that's over 200 times faster? No, 20 times faster, let's say. Or something like that. Anyway, so that's why we did that. We tested it. We did that. Submit it. All right. Let's go to My Solutions. I've got 2 of them here because I said denominator the first time. Because it's not that. It's the greatest common factor. But best practice on this one. Very much like this. And we'll see you next time.